ones up here, since they're on a frictionless surface, there's no friction going backwards, and so the only force acting on this one would be the force of gravity going down, right? And then that would be balanced out by the normal force pushing back up. Do you see how those two forces would be equal and opposite, and therefore cancel out and not add to the net force in any case? And it would be the same for this one and for this one, right? So the vertical forces are not what we're taking a look at for the objects up on the table, okay? All right, so what we want to take a look at then is really the only force that's going to be causing the system to accelerate is the force of gravity of this block right here. Now the thing to remember is, how do you calculate force of gravity in each one of these scenarios? It's the object's mass multiplied by gravity, right? Or the acceleration due to gravity. All right, and the only thing that's different is, take a look over here, how much mass do we actually have hanging? We have 2 times as much. So what would be the force of gravity in this scenario over here? The net force acting on it would be mass, excuse me, not just mass times gravity, it would be 2m times g. Are you following? So 1m, 1m, 2m. Got it? Okay, now, if you take a look, since this is the system, yes, the string is pulling this one down, but that string is also pulling on this. So you do have a tension force going up and a tension force going this way, but those are internal to the system. So those are internal forces, and they would cancel each other out. The only force that would be left over here is the force of gravity going vertical to cause the system to accelerate. So take a look at this. What's the other way we know how to calculate net force? It's force, the net force equals mass times acceleration, right? Since this problem is all about what is the acceleration in each case, what is the total mass of this system? 1 block, 2 blocks, so it has a total mass of 2m, correct? Now, what's the total force on this system? Well, since there's only 1 block, its total force of gravity would be mass times gravity, or mg, and so our net force is just the size of mg, okay? Now, since this question was all about what is acceleration, how do we solve for acceleration? Divide both sides by 2m. All right, you see that? And if I clean this up a little bit, you'll see that it's m times g over 2m. What do the m's do? Cancel out, and what we're left with is the acceleration of 1/2 the acceleration due to gravity. Okay? We repeat that process for this one. Same deal. Net force is equal to mass times acceleration. What's the total mass of this system? It'd be 3m. So 3m acceleration, and then what's the total force on this system? mg. So divide both sides by 3m, and acceleration this would cancel, and what we're left with is 1/3 the acceleration of gravity. Okay? Then take a look here at the last one. Now this shouldn't be a surprise. It's got the same mass as this one, right? But it's also got the most force hanging down. So in this case, the force is a lot bigger. So let's just set it up just like we did before. Net force equals mass times acceleration. But in our case, the mass is 3 masses. So how much will that system accelerate? If you apply a force of 2 mg on it, well, now when you divide both sides by 3m, the m's cancel, but you're left with 2/3 g. So the acceleration in this case would be 2/3 the acceleration due to gravity. And if you remember your fractions, this is the most acceleration, this is the next most, and then this is the smallest acceleration. And if you look at it, it should kind of make sense. You've got the force of 2 blocks, really just trying to accelerate 3 together. Here you have 3 blocks, but you've only got the force of 1 block trying to accelerate it, right? And here you've got a small mass, but it's also not that much force altogether. So there you are. That's how you do it. If you have any questions, talk to me in class.